Aloha, Rich Halverson. This is ITS128, and today is the 20th of September. We're in the 5th week. Let me share my screen. All right, so this is the syllabus. Let's see where we left off. Some of my classes kind of run together in my brain here. And we are in have we finished branching? Let's see what we've got here. Hello, what's going on? What did I do? Um, 4.7. Yeah, 4.7. Okay, so we got all the way to 4.7. And so let's all right, let's go to is that all the farther we got? 4.7. All right, I guess I'm just going to keep on going here I want to make sure I get through all the challenge activities for sure. Let me go to one. So let's say we're in section 4.7. We've been through, and so there is, okay, so okay, let's say I think we got through 4.7 already. Yes, it looks like we did. Yeah, we must have, there's a check mark here, which means I must have gotten through that one. Okay, so let's go to your common errors. Okay, so this is saying that when you're doing equality, you shouldn't do equality on floating point numbers, and the reason for that has to do with the fact that, you know, in the computer represents numbers in the binary number system, and we humans do our calculations in decimal, and so in the conversion, you can have something like, you know, 2.34, something computes to 2.34, and that looks exactly like 2.34 in decimal, but in binary, it might end up being a repeating number. And so to test exact equality with floating point numbers, you can run into problems with computers, and this is with all computer languages. So there's ways of getting around it. So all this is saying it's okay to compare integers exactly, but floating point numbers is not okay, and so that's why the answer to this is not okay. And this is okay in this language. Let's see. Okay. Yes. All right. So make sure you go through that and understand that. If then else statement. Fix the errors. Okay. So we have in this one here. It's pretty obvious because we are not assigning this variable equal to this number inside this if statement. We're not doing that. We are trying to test equality, so we're supposed to, should be a double equal sign when we test that. This is okay. User number is an integer, that's okay to do it this way. And so it's membership and identity operators. Okay, so there is this, when we're dealing with data types like a list or a dictionary, then there is this in operator, which where you can test if some particular value that is equal to an element in the list or an element in the dictionary. That's pretty obvious. Let's see, this is 4.9. And so make sure you understand this concept. For example, you may have a list here defined named prices, and you want to print out, and so this here, this is an actual expression that evaluates to true or false. Either 15 is in prices or 15 is not in prices. 15 is in prices, there it is, right there, that element, the second element there. And so the answer would be true. Anyway, so that's this membership in operator. And so let's do a challenge here. Let's see. We're looking at, this is a list of numbers. So we're going to read in something and convert it to an integer, just like these are integers. So we're reading in a 15. And did I press enter? Okay. Is 15 in numbers? No, it's not. It's not. So it does the else case. And so it prints out not in. And it presses, and we do the return because that's the default. And it's true. Let's do the last one. So here we have 4 things. We've got an A and a B, which are strings. We've got a C, which is a list, and D looks like it's also this list here. So now we're setting D of 0 is equal to mouse. Gee, I'm not sure. See, lists are mutable, so this should, but I don't know if it changes the C or the D. But gosh, I'm gonna test this. Okay, I'm gonna open up Python. I have Python installed on my computer, so I should be able to open up CMD. And let's see, if I go, let me see if I can see if this works. Python. Okay, so I'm in Python 3.9. I'm going to say A equals cat. Then I'm going to say B equals dog. Then I'm going to say C equals A comma B. Right, so C equals cat and dog. D equals C. And now I say D of 0 equals mouse. Okay. And now I can print stuff. I want to print D. Well, I think I have to put parentheses around it. Print D. Okay, so it did change. Okay, so how about print C? Okay, C changed also because we made D equal to C, and so that means that when we change an element in D, it also changes. It's the same as C, so it's going to change that element in D in C also. So that's what we see here. Okay, so we have confirmed that C changes along with D, because here we printed D and here we print C. And okay, so what's printed here? If A is in D, if A is D0, then print F. A is Oh, A is, I bet you A is, okay, so I'm gonna print A. Yes, A is still cat. All right, so A, is A equal to D0? No, it's not. D0 is equal to mouse. So so this does not print. Is B equal to D1? B is dog. D1 is still dog. D1 is still dog. So it's going to print G. And I got my answer wrong. Oh, that's because these are separate if statements. I was thinking it's else. Wrong. Okay, let's do this again. All right. So we have A is snake, B is mouse, C is going to be snake, comma, mouse. D is going to be snake, comma, mouse, the same as C. D0 gets set to bird, so now both C is bird, comma, mouse, and D is bird, comma, mouse. And so is B, which is mouse, is that D1? Yes, it would be D1. So it is, so it's going to print F. And then the next one is C. C is D, so C is, yeah. Is it? Print, C is D. Yes, okay, it is. Still, that's true. So it's going to print G. And the last one is A is D0. No, it's not, because D0 got changed to bird. So it does not print the H. All right, good. Okay, let's do this one. It's Boolean operators. Detect specific values. Okay, so write an expression using membership. Write an expression using membership. It means using in or not in. That prints special number if this is one of the special numbers stored in the list. So this is the special list, and it reads in a special number, and we want to see if the special number is in the special list. So it should be something like if my solution goes here, if special num is in special list, that's all it is. Do I have a quote? Oh, what is this here? I left that there. All right. Okay, order of evaluation. Okay, so there's not a challenge activity in here, but you should know this from math. It just means that you know, when you evaluate an expression like this, okay, what do you do first? Well, first you go to the parentheses. You do the parentheses things first. So first thing you're going to do is you're going to do this. You're going to add those two numbers together, and you'll get a number. And then the next thing you're going to do is you're going to multiply that number by whatever this one is. So this is going to be the second calculation that you do. And then when you're done with that, you're going to subtract D from the whole thing. So the first thing you do is the addition. The second thing you do is the multiplication. And the third thing you do is the subtraction. When you have these kinds of operators, you do you always do arithmetic kind of operators first. Those have precedence over the relational operators. So in other words, when you have something like this, you do all the calculations first, and then you do the comparison. Comparison will be last. So in this one, First, you would do this multiplication because that has precedence over addition. Well, that's not this, but this doesn't list all the order of evaluation because really these three things have precedence over these two things. So anyway, I think you know this already because it says it, you covered it before. Just remember that the relational operators, first you do all the calculations, then you do the relational operators, and then you would do any ands and ors and nots. So here, you know, well, first, okay, so there's no calculations. So first you'd figure out what this is. So parentheses. So first you'd figure out what this is. And then if that's true, you can figure out what this is. And if both of these are true, then you know this whole thing is true. Okay. So, you know, so it's either this whole thing or this whole thing, and so on. All right, and so here's a tree. This is one way of kind of representing how these precedence rules work. Start at the bottom. First, you're going to do these two things are going to be multiplied together. Okay, in this expression here, you're going to do this separately. You're going to do this separately. You're going to do this separately. And so what this is first you calculate this and this. First you calculate those two things, and those are going to be numbers. And then you see if the one number is bigger than or smaller than the other number. So that's going to evaluate to true or false. This is going to be true or false. Meanwhile, this is also going to be true or false. So now you have a true or false on this side and a true or false on this side. And so the last thing you do is you OR the two together. So only one of them has to be true, and the whole thing is true. All right, so that's just order. Make sure you understand all that. Let's see, parentheses. Okay, this is 11 code blocks and indentation. This is Python, so indentation is very, very important. The indentation means you're identifying a section of code as one single block. So if something is indented, that means it's part of a block that is subordinate to what's not indented. Like the only time this part here will execute, is if this statement is true. And so if this statement ends up being false, then you skip down to the next statement at the same level. So then you skip down to this statement. If this ends up being false, then the next statement you execute is this statement. You skip everything that's indented inside. So that indentation is important. Fix the errors on the code so the program can run. Okay, so indentation is important. See, right now you got errors. You got errors right off the bat. So you got right away, you got an error there. This is an indentation error. So, and this is something you should be able to fix without even understanding one line of code. Okay, you just understand what these statements do. You don't have to. Okay, so this indentation is wrong. Let's fix this. There's no reason for this to be indented. It's not a separate block. So bring it back out again. This here is an if statement. So what this is saying is that if this is true, then you want to execute this. Why the heck is this indented? It's not. There's nothing up above it, which would suggest this should be in its own separate block. So this should be right here. This is an else. This else goes with this if, and so it should be on the same level. And then this is what indentation is, and so this has got to be that, just that one indentation. And then this should also be indented the same. This is another statement. And this is another statement. Oh, I think that might be it. Is this it? What's wrong? Oh, okay. No, I guess it's correct. So anyway, all right, here's a fix this indentation here. Okay, so retype the code, fix the indentation as necessary to make the program work. Looks like this. Oh, we're supposed to take this and put it down here, I guess. Copy this and put it here. Okay, well, you never have to indent twice in a row. This should be indented because it's the if New York is greater than 90, the temperature of New York is greater than 90, then you want to print this. Otherwise, this is got to be the else case of this. You just indented once. This is going to be the else case of this. So if New York, if this is in this, and so it's going to check this, this is a dictionary, so it's going to check the key values. If this is the key value in this, it is, so this is true, so it's going to do the true part. Then it checks to see if what the temperature is, otherwise if it's not in there, then it's not going to do this part. It'll do the else part. All right, so anyway, that's this. I'm sure this is correct. No. This should be back here. It only needs to be indented once. What's the input? So that's interesting. I'm curious now. Does this? I'm gonna copy this. Copy, and I'm gonna open up Notepad. Here's Notepad. I'm gonna paste it in the Notepad, and I'm gonna save it on my desktop. Whatever, right here, right on my desktop as a Python program, test.py. And then what I'm curious about is when this thing executes, when does this input execute? Does that input execute at the very top when this thing is executed? Or does this input get executed when this gets when the value for temperatures of New York is needed? So I'm going to see what the answer to my question is. Let me exit the Python interpreter here. Let me go to my, I think I have to go to OneDrive first. And I go to my desktop. And I do a dir, and I see here's my test Python program that I put right here. So I'm going to execute that Python program, and I'm going to do this. Enter a temperature for New York. Okay, that's so I know when it's being asked. So I'm going to do Python test.py, and did I not? I didn't save it. Darn it! So it must be asking me right now. I'm going to say 85. All right. I forgot to save the file. When I made this change, I forgot to save the file. So I got to save the file. Now let's run it again. And we see right off the bat, it asks me for the temperature for New York. So when the parser scans the program before it executes it, it must execute this right here. All right. So anyway, this looks like it's the correct answer. Oh, it is the correct answer. Okay, what's next? 4.12, conditional expressions. So this is a weird statement in Python, which they don't have these statements in this. Java has got that question mark statement. Anyway, the way this works is there's an expression that will be executed. So this is all going to be on the right side of an assignment statement. This is the right side of an assignment statement. So on the left side, there's going to be a variable, and then this whole thing is going to evaluate to something. Okay, this whole thing is going to evaluate to something. And what's it going to evaluate to? Well, first we look at expression, or first we look at this condition, and this condition is going to evaluate to true or false. When this condition evaluates to true, then this expression is evaluated, and the variable gets set to the result of calculating this. Otherwise, it's this. So, so here, what would be equivalent to this? If some condition is true, you set my variable equal to expression 1. Otherwise, if the condition is false, then you set my variable equal to this expression. Okay, that is this. Instead of doing it this way, you can do it this way, where if this condition is true, then set my variable equal to this expression. Otherwise, if this condition is false, then set my variable equal to this expression. And of course, these expressions are not going to be evaluated unless the condition is right. So, you know, that makes sense. Okay, so that's what the way it works. So let's do this one. Let's do this one. My number is set equal to 4. And then what is your number equal to? Well, let's see. Let's evaluate this. My number is 4. If my number is less than 4, it's going to do this one. But my number is not less than 4. It's 4. So this is false. So this is the one I take. So I take this and set your number equal to this. So printing your number is just going to print 2. All right, let's try the hardest one. My number is equal to 10 if my number is equal to 6. No, it's not equal to 6. So we ignore this one, and instead we do this one. Well, what is that? My number is 10, and we add 4 to it. And now the result of this expression is 10 plus 4, which is 14. So 14 gets stored into your number. So your number is 14. Thanks. Okay, this one. Create a conditional expression that evaluates to this if this is true. Otherwise, the string gets set to non-negative. Okay, so and it's going to be this thing. So we read in an input, and then we take a look at that input. If it's true, wait, what's true? If our expression is true, we're going to have an expression if user val is less than 0. Okay, so that's the expression, and we put a we put a else here. So it's going to be on this side of it, it's going to be what it is when it's true. And when it's true, it's going to be, we want it to be negative. So this is the expression which evaluates, and all it is the string negative. That gets stored into here. If this is true, if this is false, then this gets stored in there, which is the string non-negative. And this is Python, so we don't have to put any semicolons anyplace. And so let's just run this and see if it works. All right, I'm sure that'll work. The next one here is using a conditional expression, write a statement that increments num users if update direction is 3. Okay, so if update direction is 3, if update direction equals 3, okay, equals 3. If update direction is 3, then else, okay, so the false case goes here. Decrements num users minus 1. Oh, num users equal, oh, num users minus 1. It's just the expression minus 1. Num users equals num users minus 1. That's if it's false. If this is true, then num users is equal to, oh, I guess num users plus 1. So it increments num users, it increments it by 1. It doesn't say by 1. It means by 1. When it doesn't say what to increment it by, then we assume it's 1. So anyway, so if this is true, then it's going to do this one. Otherwise, it's going to do this one. So let's see if this is right. All right, what's next? 413. There is no challenge activity here. In fact, it doesn't look like there's even any participation activities. So you can see what this does. It reads in, it asks the user to enter in some abbreviation, and it's able to handle these abbreviations. And what it does is if it gets any one of them, it prints it out. Otherwise, it doesn't know the answer. All right, so let's do this lab. Smallest number. Write a program whose inputs are 3 integers and whose output is the smallest of the 3 integers. Okay, so all right, so there's several ways we can look at this program. And but basically we have to find out, basically the answer is going to be, the answer is either going to be 7 or the answer is going to be 50. The answer is either going to be the first integer, or the answer is going to be the second integer, or the answer is going to be the third integer. Okay, so so I think we can do something like there's lots of ways we can start this, but let me just go with this. I'm going to say, oh, we have to ask the user what the numbers are. Input 3 number. Okay, so I'm going to say first is equal to input, and I guess we're looking at integers, right? So let's integerize this input. Int I'm integerizing the input. And that's the first one. And the second one is going to be second and third. So the second number is going to be here. And the third number is going to be here. Right? Now, if, in fact, here's what I'm going to do. I'm going to go over here, copy this, and I'm going to use my thing over here. I'm going to type it in here. And so I'm going to say, because I'm going to do this, can I? Yes, I can't make the. Oh, do that. Okay. Oh yeah, size. Change. There, that's better. First is going to be. I'm going to read in the enter first number. And this is going to be enter second number and enter third number. That way, I know what the computer is asking me for. Okay, now, and then if something, then I'm going to print out the first number, then print first. Okay. Else, elif, and I can do it this way, elif something else. I'm just going to go like this. This is something else. Then print out the second number. Otherwise, if it's not any of those things, I can say else print the third number. Okay, so that's what the answer is going to be. And so now I just have to figure out what to put here. When do I print out the first number? Well, I print out the first number when the first number is greater than the second number, and the first number is greater than the third number. That's when I print out the first number. I'm doing the largest, right? Not the smallest. Oh, the smallest. Okay, smaller. If that's true. I have to care about the equal case, don't I? Smallest of the three values. Okay. Okay, so if first is less than or equal to second, and first is less than or equal to third, then we print out the first. If second is less than or equal to first, and second is less than or equal to third, then print out the second. Otherwise, it's just going to print out the third. Okay, that's what I'm going to guess. Let's see what happens. I'm going to save this. And what happens when I run it here? Oops. Oh, let me just run this. Enter the first number. I don't know. Well, 7, 15, and 3. And outputs 3. Okay, well, I should try other ones. 7, 15, 8. Yeah. What happens if I go 15, 15, 15? Oops, no. 15, 15, 15. Okay, anyway, so that's my answer. I'm pretty sure this is right. I'm just going to test it and see. Copy this and put it here. Oops. Except for, don't put these things there. I'm just going to see. Good. All right. So there's a bunch of other convoluted ways that we can arrive at the right answer, but just all you got to do is make sure is you know, when you're answering the first one, you got to make sure that it actually is the smallest one, and same with the second. And if you've eliminated the first case and the second case, then you automatically know that it's the third case. All right, here's exact change. Okay, so for this one, write a program with total change amount as an integer amount, and output the change in the fewest, using the fewest coins, one type per line. Okay, so first we're gonna so we have some amounts, and then we're gonna extract out the number of dollars, and then we're gonna take what's left over, which is gonna be less than $1, and we're gonna see how many quarters we can get out of that. And once we do that, we're gonna take what's left over, which is gonna be less than a quarter, and we see how many dimes that is. And once you figure that out, once we take the number of dimes out, then what's left is going to be something less than a dime, and so on. So, and if it's 0, okay. So we're going to read in some number. Yes, we got to read in some number. Change equals some integer. We use integers, right? It's giving you an integer amount. So that's how many pennies. Integerize the input. Okay, we're going to read it in. Tell you what, I'm going to do this so we can see what we're doing here. So I'm going to say first we're going to change. You're going to get some change, and that's going to equal to integer value of an input, and enter number interchange amount in pennies or cents, I guess. And then first we're going to take out the number of how many dollars goes into that. So I'm going to say dollars equals change integer divide 100. Okay, so if it's $5.08, if it's $5.82, we take 582 and divide it by 100. Getting the quotient, so that would just be 5. So this is the dollars and the remaining change. So I'm just going to say change, remaining change. I was going to say change again, gets changed to change mod 100. So if it starts out 582 divided by 100, integer is 5, the remainder of 82. 582 mod 100 is just 82. So this is now equal to the change after the dollars have been taken out. And so next we can do quarters equals change, the new value for change, divided by 25, and then change is equal to change mod 25. So that's how much is left after the change. And then, so I think you can take it from here, but what I'm going to do is I'm going to print out oops, where am I? I'm going to print out dollars, print dollars, I'll just do that, and I'm going to print quarters, and I'm going to say print pennies. Okay, so the rest of it rest. I'm going to say change do the rest. Okay, so I'm going to run this, save it, and I'm going to say run it, python.test.py. What is it? So I'm going to say $5.82, and I get $5, 3/4, and then there's 7 cents left. So $5 brings it up to $5, and then 3/4 brings it up to $5.75, and then 7 more brings it to $5.82. But really, there's a nickel in there and 2 pennies. Okay. The other thing I think you're going to have to do is do the singular plural thing. Okay. So you say like 1 penny versus 1 pennies. Say 2 pennies, 1 penny, 0 pennies, 1 penny, 2 pennies. So if it's anything other than a 1, then it's plural. So 0 pennies, 1 penny, 2 pennies, 3 pennies. Same with quarters and dollars and everything else. So so that means you got to do something like if dollars equals 1, then print dollars, comma, dollar. Else. Okay, so that's how you take care of dollar. That's how you take care of it. Okay. If you do if quarters equals 1, then you're going to print out quarters. Well, it's this 1 1/4. Because you know it's 1. Oops. Oops. Else print quarters. So if you do end up with let's say it's let's say it's $5.35, that's only going to be 1/4. So if I do 5.35, it says $5 1/4. Or if I do 5.55, it's going to say $5 2/4. See, so anyway, that's how you do that one. You can do the rest. All right, what's next? Leap year. Oh man, this is a real hard one. This is a real hard one. All right. A year in the modern Gregorian calendar consists of 365 days. Really, it takes a little bit longer to rotate around the sun. So every now and then they got to throw in an extra day. And it turns out that every 4 years, it's about where every 4 years we throw in an extra day, except for that's a little bit too much. So every 100 years, we do not throw in the extra day. It turns out that that takes us, so we still need a little bit more. So then every 400 years, we actually do throw in that extra day again. Okay, so you got that. So the requirements for a leap year are the year has to be divisible by 4. Okay, so it's got to be all these things. If the year's got to be divisible by 4, except for if the year is a century year, then instead it's got to be evenly divisible by 400. So so the year 2000 is not, oh, the year 2000 is a leap year, but 1900 was not a leap year. Because 1900, although it's divisible by 4, it's not a century year. Or no, it's not divisible by 400. 1700 is not divisible by 400. Neither is 1800 or 1900. 1600 is, and 2000 is. So that's why we didn't have to worry about this rule when in the year 2000. Do you remember back the year 2000? I do. That was the Y2K thing. So it turns out 2000 was a leap year. All right, so how do we write code to do this? Well, let's try to get that in there. Okay, so I'm going to say first you got to read in the year. Oh, we read in the, okay, so we're going to start out with is leap year. And so we're going to start out by saying the default is going to be false, and then we're going to do some tests, and if the tests come out right, it'll get switched over to true. Okay, so first we're going to default. We're going to start out saying, well, it's not a leap year until we can prove it is a leap year. So let's read in a year, input year. I'm just going to say year. Year equals, oh, I guess I got to say input year because I want to paste it back in here again. Input year equals integer, the integerization of the input. And then we're going to do if year is divisible by, if the year is divisible by 4, okay, first of all, if the year mod 4, if the year mod 4 is not equal to 0, if year mod 4 is not equal to 0, in other words, if the year is not divisible by 4, then for sure it's not a leap year. Okay, so I'm going to take care of that case right now. Print year is dash not a leap year. Okay, so that's a for sure. Else we know that it's divisible by 4. So if it is divisible by, if it is not divisible by 400, if year mod 400 is not equal to 0, that means if it's not divisible by 400, then print year is not a leap year. Otherwise, if it's divisible by 4 and it's not divisible by 400, then it is a leap year. Print year is a leap year. And then is that it? All right, well, I'm going to try it. Enter a year. All right, so try it. Let's try it. So I'm going to first type in 1712. Oop, 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 oop. Forgot. Don't change the name of the variable in the middle of the code. Don't change the name of the code. I could have just changed them all the year. Probably should have. No, I couldn't, because I want to be able to copy. I'm going to copy this right down into here if it works. Okay. So let's see if this better save it. Save. And then let's run this. Run it again, and I'm going to say 1712. 1712 is not a leap year. Oh, it is a leap year. Darn it. Code is wrong already. It's smaller. All right. Why does it say 1712 is not a leap year when it is a leap year? Okay, so if it's it is divisible by 4, so it should be down here. Is it divisible by 400? Oh, wait a minute. I bet I have this wrong. It must be evenly divisible. It must be divisible by 400. If it's a century year, it must be okay. Okay, maybe let me do this wrong. I'm not testing this right. First of all, if it's a century year, I got to see if it's a century year first. I can't do that. I shouldn't do that test. Okay, so if it's if input year mod 100 equals 0 and input year mod 400 does not equal, this is what it should be. Okay. If it's not divisible by 4, it's not a leap year. If it is divisible by 4, then if it's a century year, then it cannot be divisible by 4. Then if it is divisible by 400, it's a leap year. Otherwise, it's not a leap year. Okay, I'm going to see if this is right. I'm not sure if it's right, but I'll be able to test it. This is where trial and error comes in. This is what's great about coding, is you can just do trial and error. If you were an electrical engineer, you can't do trial and error. You might blow something up. So I'm going to run this again, and I'm going to say, what am I doing wrong? If this is equal to that. Oh, wrong language. And guys, again, 1712 is a leap year. 1913 is not a leap year. 1913 is not a leap year. 1900 is not a leap year, whereas 2000 is a leap year. Well, I'm just going to try. It's the first time I've ever done this. Done this just off the fly like this, and if this works, then it'll be fantastic. Submit. No, oh, I gotta paste it first. Paste it, and submit. Yeah. All right, well, anyway, you can fix that. You see what's wrong, right? Okay, so you can fix that. Oh, we're at the end. Loops. All right. You know, I think I've covered everything in the chapter. I don't need to go forward, right? Let's see. Let's read just chapter 4. Let's see if I'm a week behind or anything. This is the 20th. Ooh, I am a week behind. Let's start loops. Okay, loops. Very good. A concept of a loop concept. It's like an if branch, except for with an if branch, if you take the branch, if you take the if case, if it's true and you take the indented part, when you're done with the indented part of an if statement, when you're done with the indented part, you just go on, you just continue on. You're done with that, and you go on to the next line. If it's a loop, then you go back up to the top and you test the condition again. So you know, it's like here you're gonna, let's say you're driving your baby around. As if you ever experienced this, I remember my daughter was young. She used to like to ride in the car, and so my wife or I would drive her on until she falls asleep. And so here's what you might do: is you might drive around the block here, and by the time you get to this, you get to here, is the baby still awake? If it's still awake, then you keep on driving around. If the baby's not awake, then you can take the false case and go back home again. Here's summing input values. You're gonna add up a bunch of numbers until you get a minus number. So you start out the sum is 0, you get the first input. While the value is greater than -1, in other words, while the value you're reading in, while it's not -1 or less, while it's greater than -1, then add it to the sum and read the new one, and then you go right back around again. So you keep on doing this loop while the user is inputting a value that is not greater than -1. So it's very important in these loops to that as you're in the loop, something at some time will cause this condition to be false. Because if you have some stuff in here and it ends up never, you're coming back around again, if it never becomes where this is false, then the loop will never end, and then you have what's called an infinite loop. You don't want to have infinite loops, because you have to wait till the operating system is noticing that, oh, there's a process that's running way too long there. We better stop the process. All right, so that's an infinite loop. Make sure you do these participation. Oh, here it's increment if a negative value is seen. So you just. Oh, I'm doing next value. It's not. I don't have to increment because it's not negative. Whatever. Okay, you can do that. All right. You can do this one too. Let's see, while loops. All right. So while loop it's a construct. It's called a construct that repeatedly executes an indented block of code known as the loop body, as long as a loop's expression is true. So as long as this is true, this body gets executed. So there's got to be something in this body that will execute, and it'll eventually make this expression be false. So here, for example, and so here, like you are reading in a new value. So each time this thing executes, it's possible that it'll evaluate to false. Okay. So that's how this works. Make sure you understand, go through these exercises here. Assume that the user would enter N and then N and then Y. So what are you supposed to do here? You're supposed to, for each question, indicate how many times the loop body will execute. So gets the character from the user, and then the user has entered N. So this executes. And then reads it again, and the user enters in N again, and then it doesn't execute. So it looks like it only executes once. Oh, it executes 0 times. It's not equal to N. Oh, it is equal to N both times. Okay, never mind. See, I read this backwards. So user enters an N, and the only way this would be true, or this is not true because the user did not enter, the user entered an N, and this is only true if the user did not enter an N, so this is never executed. All right, you make sure you understand those. Where's a challenge? Let's do a challenge. Okay, here we go. Enter the output of the while loop. Okay, so we have a while loop here. Start it out. So here's an example, and you should always take a look at this. We're testing the value of G, and if G is under a certain value, then it's true and it continues. And inside someplace in the loop, and here it is, we're incrementing the value of G. So it looks like this loop will eventually end because this will eventually get bigger than 1. So, but here we go, it's 0, and if while G is less than or equal to 1, print G. G is 0. And then we're going to add 1 to G. And so now G is equal to 1. So we come back around, is G less than or equal to 1? Yes, it is less than or equal to 1. So print it out. And then add 1 to it. Now G is equal to 2. Come back around, is G less than or equal to 1? No, it's not. So it's done. So the loop is done. And so this is all that prints out. Is this correct? Yeah. Well, let's do the hardest one. Okay, G starts out equaling 3. Is G less than or equal to 5? Yes, it is. So print out the 3. Add 1 to it. Is 4 less than or equal to 5? Yes. So print that out. Is 5 less than or equal to 5? Yes. Print that out. Is 6 less than or equal to 5? No, it's not. So we're done. And we're done. All right. Very good. What's the next one? Basic while loop with user input. Okay, so here it's going to require that the user eventually inputs something that's going to cause the expression to go negative. And what is the expression? As long as the user enters a non-negative number. So as long as the user enters a non-negative number, the expression that executes, write an expression that executes the loop body as long as, okay, so that would be as long as the user num is entering is a non-negative number, which means it's got to be greater than or equal to 0. As long as it's greater than or equal to 0, then it executes the body of the loop, reads in another one, integerizes it, and so let's see if this is right. Okay, what's this one? Write a while loop that repeats write a while loop that repeats while user number is greater than or equal to 1. While user number is greater than or equal to 1. In each loop iteration, divide the user number by 2. Okay, user number. It's an integer, so it equals user number divided by 2. And then print user number. Print user number. Okay. Whoa. Why is it 0.0 here? I must do this. I'm gonna do a. So let's see that. See what happens. Okay, so it must turn into it starts out as an integer, but then the result of this is a floating point number because it's an integer. It's a it's a floating point divide, not an integer divide. So then this will ends up eventually being turned into a floating point number, which this would not work in Java, but it works just fine in Python. And so that's the answer. All right, what's the next one? It's 5.3. Got 5 more minutes. Let's do more while loops. Greatest common divisor. Okay, so we're going to see this a lot. Is there a okay? So this greatest common divisor, it keeps on dividing. It finds the biggest number that can be divided evenly into two numbers. So if you want to find the greatest common divisor for two numbers, you're looking for the greatest, the biggest number that will divide into both of them. And if you cannot find a number that's bigger than 1, if you can't find a number that's can be divided evenly into both of them, then you know that those two numbers are relatively prime. They're prime with respect to each other. And because there's no common divisor that can go into both of those numbers and it's greater than 1. And so when you have two numbers that are relatively prime and they're big enough, then they can be used as a public key, use a public key encryption. Anyway, so this algorithm is nice. It's if some dude long time ago named Euclid figured it out, and it just starts by it reads in two numbers, and while they're not equal, and you keep on either you subtract one, you subtract the smaller one from the larger one, and then they end up trading places, and you continue this loop until you end up with where these two numbers equal each other, and then you know you're done. So anyway, this ends up finding looks like 5 is going to be the greatest common divisor. So anyway, so here's a challenge. Okay, current. Okay, so this one, while loop with a sentinel. A sentinel just means that there's something in the input that's going to cause it to stop. And in this case, we have a while loop here, and it reads entered values, keeps on reading entered values until the entered value causes this expression to fail or to be false. And so the 0 is the sentinel value. Once the sentinel value is read, then that causes the loop to stop. So let's do this one. This is the input, and we're supposed to see what first of all, it reads in a 6, and it sets this value called this variable minimum value. It sets that equal to 6. Well, the entered value is greater than 0, so it's going to be greater than 0 for all of these. If the entered value is less than the minimum value, then it resets this variable equal to that value. So in other words, this thing is going to go through all these numbers, and it's going to and we want to save the smallest one. So it keeps on testing the new one with one that we've already believed is the smallest one. Test the new one. If it's a new smaller value, then that gets stored in there. So so we're supposed to see what the output is. Well, the first time it's 6, and then it sets minimum value equal to 6. It's greater than 0. So if it's the entered value 6 is less than or equal to 6, it's not less than or equal to 6. So we skip this and we read another one. Oh, are we just printing out? Oh, we're just printing out the minimum value. Well, that's just this is too easy. I'm just going to put the answer in here. Min value is going to be it's going to be 2. Oh, wait a minute. Yeah, it'll be 2. It'll be 2. All right, let's do the last one here. Okay, so we read in an age, we read in 65. If 65 is less than 15 or it's greater than 30, it's greater than 30. Then if it's less than 15, it's going to say yeah, it's not that. Otherwise, it's going to say already an adult. So it's going to print already adult. Enter. Then it's going to read in another age, and that would be 35. Reads in another age, comes back around. Is 35 less than that? No. Is 35 greater than that? No. 35, so this thing fails. So then it comes down here and says perfect match, I guess. Perfect match. Okay. I made a mistake. See a mistake I made. I said 35 was not less than 30, or was not greater than 30. It is greater than 30. Let's do this again. Okay, so is 12 less than 18 or greater than 30? Yes, it is. So I'm going to print less than 18, so say too young. And then it's going to read in the 18. Is 18 less than 18? No, it's not. Is 18 greater than 30? No, it's not. So then it's going to skip out and say perfect match. Does anybody know if I'm doing this wrong? Let's see. So it reaches 18, it's going to skip out. Yeah, okay, we'll just see if this is right. All right. Okay, what's this one? I'll just finish this and then we can, I'll just finish these two and then we can go to counting next time. Okay, bidding example. Write an expression that continues to bid until the user enters N. Until the user enters N. Oh, okay. All right, well. While keep bidding, while keep bidding is not equal to N, then keep bidding. All right. Okay, one more. Given positive integer num insects, write a while loop that prints, then doubles num insects each iteration. Print values less than or equal to 100. Follow each number with a space. Okay, so it reads in a number, and then each time it goes through the while loop, it doubles it until it gets to 100. So while num insects is less than or equal to 100, then print num insects, comma, and equals a space. Okay, so reads in a number, prints the number, then doubles it. Then prints the number, then doubles it. Okay, so num insects times 2. Times 2. So this is going to change num insects each time. Okay, let's see what this does. All right. Okay. So I wonder if this would work. It shouldn't. This should fail, but it probably doesn't. Aha, yes, it does check for that case. Okay, that's good. All right, so yes, it should be this. Okay, all right, well, it's and so I've taken you up to 5.3, and so next class we can finish loops and probably get going with functions. You have any questions? All righty. Okay, I will see you next time. Thank you. Thanks for watching.